Hey, everybody. Thanks for joining us. It's another meeting of the Research Triangle User Group. My name is Mike Kanakis, and tonight we are excited to have our guest speaker, Anthony Nocentino, here. Anthony is a Principal Field Solutions Architect at Pure Storage, a Pluralsight author, and a Microsoft MVP. He is well known in the community. He's always been a very willing participant in sharing in the community and loves to talk about things like Kubernetes, containers, and all kinds of stuff like that. So we're going to have a great presentation tonight. So let me start off by welcoming in Mr. Nocentino. How are you?
Good, sir. Thank you for having me.
All right.
I really appreciate that.
Sure. Well, we are very honored to have you with us tonight. What are we going to be talking about tonight?
So this tonight is going to be kind of the intro to containers, but I kind of know the audience a little bit. So I'm going to kind of push some boundaries in a couple of areas with how like containers work and how they're built, and some, not to say advanced scenarios, but kind of drive towards like what I think you guys might be interested in the PowerShell community.
Awesome. So if you are watching this on YouTube and you are not joining us live during this, I invite you to stick around because Anthony is a fantastic speaker and I've seen his demos. He has some great content to share. You're bound to learn a lot of things tonight. So if you're just joining us on YouTube, get settled. You're in for a good view here. So with that, I'm going to turn it over to Anthony and I'll let you take it away.
Cool. So I'm going to share. I'm going to click on you. So, all right. You guys see a slide deck, hopefully? Yes. Yeah? Good?
Yes, you're good.
Cool. I can't see the chat. I'm in presenter mode. So if like there's a question that comes along the way, just dovetail it in, if you think it's important to get out. Otherwise we can take them, whenever we want to take them. So let's talk about containers. You better get on board, the PowerShell edition. I did this session at PowerShell Summit 2019, back when we did things in person. That was so much fun. And the food was always better. But I kind of took it, upgraded it yesterday and added some additional content for tonight. I can go as long as you want to go. I was joking with Mike earlier. I can do this for 45 minutes or 4.5 hours, wherever you want to land. And so we can just kind of keep jamming out about containers and PowerShell and how I use this stuff in doing the things that I do. Mike introduced me. I'm Anthony Nocentino. Recently went from being a self-employed consultant for the last years to the principal field solution architect at SQL Server, or at Pure Storage, focusing on SQL Server. It's been a fun ride. I've been there about 3.5 months. I am learning so much stuff. I've been a data platform MVP for the last 5 years. Super fortunate for that. There's my contact information. The email address still works. I just migrated my blog over to a new URL. And I'm on Twitter a lot, probably more than I should be. But it's kind of my main way to interact with the community. So, feel free to follow me on Twitter. If you have any questions, either email me or shoot me a DM. And as Mike indicated earlier, I think I'm up to 23 Pluralsight courses now, mostly on Kubernetes, a bunch of Linux stuff, deep dive stuff, and some AKS stuff that I've been partnering with a friend of mine named Ben Weissman to get some good content about AKS out to the community. Also, if you want access to that Pluralsight content, shoot me an email and I'll give you access to that for free. I have free trial access codes that I can give you for 30-day access. So no sales pitch. I want you to have access to that content if that's something that you're interested in. Cool. So today we're going to talk about basically what is a container, right? Like we're going to kind of look at the internals of a container and kind of describe like what it is. We'll look at the container universe. There's a lot of stuff out there, a lot of tools, a lot of terminology. And I kind of want to give you the lay of the land on how, what's really out there. And we're going to jump right into working with SQL Server and working with PowerShell and containers. If you're thinking, well, why would we look at SQL Server and containers? It's really a common application that we're all kind of familiar with as Microsoft professionals in our data center. So we kind of have a good idea of how it works. It's the way I got started working with containers. So I kind of have a bunch of content and understanding about how it works. And then we're going to switch gears after we talk about how SQL Server works in a container and talk about how PowerShell works in containers. And then we're going to do pretty much as many demos as you want. I just looked, I have like 300 lines of PowerShell or code to go through. It doesn't sound like a lot, but it is, to kind of grind into lots and lots of demos. And then we'll wrap it up with container orchestration, or the need for container orchestration, and how you can use container orchestrators to do like some really cool things and a lot of work. Before I did this session in 2019 at PowerShell Summit, like I really wanted to just toss the decks out the door and just do demos the whole time. But since this is introductory, there's some foundational knowledge that I wanted to bring to the table to everyone to kind of bootstrap you, and then we can dive into the demos. So probably I think it's like 7-8 slides, and then it's straight demos after that. And so what is a container? Well, for years and years and years, we've been used to doing things like building virtual machines and then running operating systems on top of that, and then deploying applications on top of that. But what a container does is it virtualizes the OS. Like, it's such an overloaded term. I'm virtualizing the OS. But what I'm really doing is kind of making little boundaries around processes so that when they run on an operating system, well, they think they're the only thing running on that operating system. And so we can share the kernel and the underlying system resources of that OS, right? And I can run lots of applications that potentially would conflict, or historically might conflict with each other, on top of a single operating system, and not really have to worry about that anymore. And we'll see that in action today. And so what is a container? All a container really is the binary, the libraries, and whatever other components that are needed to run an application. It's literally just that. All a container really is a binary. And then you can start it up and have a running process that thinks it has access to the entire underlying OS. Generally speaking, you're going to have one application inside of a container. I'm going to show you one at the very end of today's session that has like a bajillion applications inside of a container. But when we're talking about building applications to containerize to run in production systems, generally speaking, you're going to have a single application because it's the unit of work, right? It's a process. It's thing getting scheduled onto a computer and started. Containers are also ephemeral, kind of using that process analogy. Again, I start a process, I can stop a process. If I stop a process, I want to lose all the state associated with that process, right? Similar thing with containers. I can start a container, I can stop a container, and I can delete a container, right? And so this ephemerality, historically, which could be challenging for persistent state applications like database systems, actually really kind of unlocks a unique thing that we'll talk a little bit about later when we start talking about how decoupling data and computation. So yeah, super advanced graphics. I have an application that's inside of a container with some binaries and libraries, and that's it, right? That's the thing. To be super pedantic, the thing is the container image, and I start a container from the container image. And so that's really the terminology. You'll see them kind of used interchangeably a lot, but you could distribute and exchange container images. You start a container from a container image, and we'll see that in action a whole bunch today. And so let's start off with a comparison. We'll look at VMs. And I kind of alluded to this a second ago, but for years and years and years, what we did is we bought some physical servers, we put them in our data centers, and we installed hypervisors on them. ESX, the 2 or 3 people that actually installed Hyper-V, and we used that to then install a guest operating system on top of that. And then we could kind of really start packing and increasing the density of things in our data centers, right? Because I remember the days where I had to buy like a web server and a SQL server and like physically deploy that in my data center, and that thing be like 6% utilization. Woohoo, right? But we could get a lot of density and start building systems that were getting higher utilization, so we could physically reduce the capacity of stuff in our data center. And then we started installing applications on top of that. So app 1, 2, 3, 4, super complex application stack there, right? And I like to say that this thing is high maintenance, right? Because what we would do is professionals, especially the PowerShell folks, right, might be a little bit more advanced in this, but we'd set this stuff up and we'd leave it alone and we'd never touch it. And we'd have like change management processes around every time we had to touch it. And it was fragile, right? We wanted to make sure that this thing stayed in this state all the time. And that got to be really hard to do, because if I have to manage all of this, so what's so hard about that? Like, what's so hard about virtual machines? Like, why is that thing challenging? Well, first off, I have to spend a bunch of compute capacity supporting all of those guest operating systems, a lot of memory, things like that. Yeah, there's page deduplication, and I can like over allocate CPUs and things like that in a virtual environment. But when I was working, when I was in graduate school, I did a bunch of work with grid computing, and one of the, and it's about specifically about scheduling. And one of the workloads that I read about in a research paper at that time was Windows updates. Like, how it was such a demand within a data center that someone did an academic study on how hard it was computationally in a data center to run Windows updates, right? Because I think, right, and you do that across 10, 1,000, 100 instances of Windows, that really burns a lot of capacity. Whereas, like, especially if you're in the cloud, that's capacity that you could be selling to somebody else, right? Patching is always super hard. I have to deal with operating system patching, not very fun. Troubleshooting, right? Those applications and those VMs and all that stuff. If I put those things in that exact place and I want them to stay there, or I want them to be awesome, if something went wrong, I had to put my cape on and go figure it out. And that can be very challenging, right? I have to go troubleshoot and make sure that these things are always up and running. I like to say that the hardest thing to do in IT is to upgrade an operating system, right? I think it is, because what do you have to test when you upgrade an operating system? Everything, right? Every possible application, drivers, networking. If you're using any sort of clustering technology, all of that stuff has to get revisited every time you have to upgrade. And then deployments. I can be a little bit more loose about this one when I talk to PowerShell folks. I mean, how many folks in the audience have fully automated deployments of virtual machines, Windows operating systems or Linux operating systems, and then the applications on top of that? I would expect more hands in the audience here, but if I talk about this in a SQL Server community, I might get 4 hands in the whole audience. And in fact, I did a very scientific Twitter poll. I think it was like 40% of people are using any sort of automation to install SQL Server, just SQL Server. And 60% of the people that replied to that poll were clicking next, finish still, right? And so this stuff, right? Does any of this stuff move your business forward? Does it provide value to your organization for you to do patching? Yeah, security. But I mean, you could be doing other stuff that's more high value, like automating the heck out of your environment to make sure that your deployments go faster. Because when the deployments go faster, that means you're getting stuff done that provides value to the business, rolling out new code, rolling out new applications, whatever that is. And so containers directly attack those problems, right? When I'm talking about a container, I can run a container on a physical or virtual machine and just install a regular base operating system on there. There's Windows containers, there's Linux containers. I'm not a huge fan of Windows containers because of reasons. We can talk about that if you want to dive into it. But predominantly, you're going to see Linux containers in enterprise environments. And when I want to run an application on top of an operating system and consume the resources of the OS, I will go and get a container image and I will start that process on the base operating system. All of the stuff to run my application is in that container, right? I don't have to go and configure all the things and get it all up and run it. That's a self-contained thing that runs my app. And I can run multiple applications on top of this operating system and consume its services. And then I can run across multiple physical or virtual machines and run a whole application stack, right? And I like to think that this is lower maintenance because there's less stuff that I have to worry about inside of my data center, right? I could just focus on getting my apps up and running. Right. And I think that's going to provide a lot more value to the organization because whenever I want to go and have to service this app, I can just delete that container and redeploy it with the new version of that application, like whatever it is. It could be a security patch inside there. It could be a version change inside my app, a new code rollout. It could be a brand new installation, whatever that is. This idea of being able to destroy and redeploy is super valuable. And you're going to see me kind of drive that point home over and over and over today in the session. So that's kind of the base. Like that's what a container is and like the value that it provides. And it directly attacks those problems of maintenance really and deployment time and adding speed to getting things done, right? That's really what we're going for. So let's shift gears. Sir.
Hey, yes. Anthony, just wanted to let you know when you think the time is right. There was a question from the audience if maybe you could talk a little bit about your hesitation or about Windows containers. Okay. And if that's not right now, we could do it later. But
no,
there's a question about that.
Now's a good time for that. It's getting hot in here, like an Ellie video. I got to turn my air conditioning on, even though it's not hang tight. So Windows containers versus Linux containers. Okay, so you can do Windows containers right. It's just harder. And the reason why I say it's harder, and I'm going to talk about a specific scenario that I was involved in. Because it kind of highlights all of the things that make Windows containers challenging. So I had a customer back when I did consulting, sort of days. And no, I love what I do now, just kidding. And so they took a regular old .NET application. They put it inside of a Windows Docker image. They pushed it into Kubernetes and were like, that's going to work great. All right. So if anyone's ever worked with any full .NET application, when you go and hit that application for the very first time, on an IIS box, what's the first thing that happens? Nothing. You wait 20 seconds till the application loads and like all the JIT compilation happens and rolls it out, right? And actually gets up and running. And so that's one of the big things. Memory footprint is another big one. there's just Windows containers versus Linux containers. They're just titanic in size. You're going to see a little bit later. I can roll out a SQL Server, and it's a 1.5 gig image to run a SQL Server. Now, yeah, I have to have the space for the data, but juxtapose that with the Windows container that runs SQL Server, I think that was like 13 or 20 gigabytes in size. And so that sounds trivial in a modern data center, but if I have to go and move that amount of data to roll out an application or scale an application and wait 20 seconds for it to start up, that is kind of really opposing, like pushing against the whole reason of containers is agility and speed, right? So if I have to build a new image and roll that out, that's challenging to do too. What's up, Mike? Yeah.
So when you talk about a Windows container and it not being that efficient, I am very green to the container world. So does a Windows container basically contain the GUI itself, or is this supposedly a stripped down Windows version?
It's a stripped down version of Windows.
Okay.
I don't know if it's precisely core or not, but it's definitely a smaller version of Windows. It's an architectural thing as to how Windows is set up versus how Linux is set up, and we can kind of get into that. But effectively, the security subsystem has to be pushed into the container image, and there's a lot more stuff that has to be available inside the container for a Windows process to execute. Now,
so essentially, it's just that Windows is just not very svelte, right? It's never been. It's never been Windows sort of tip of the hat to say that, look, we have this really thin OS that doesn't require a lot of disk. Windows has always been like, look, this is what we do, and this is what you need, and that's what you got to do. So basically, it sounds like that paradigm follows its way into the container as well.
Right.
There's just no way to really run Windows thin.
Right. You've seen it in core. Like core's not exactly tiny. It's better. It's not tiny though. I can, if I want to run, I'll show you some container images today that are, sub 60 megabytes. Right. So imagine, that's pretty darn tiny. Now I want to say this with a caveat, you can run full .NET Windows containers. You just have to do the stuff right. And it's just harder. And so one of the things I've refused to do as a technologist is totally write off a technology. It's kind of like I make the joke to like the friends and family, I don't like olives, but I eat an olive every year just to make sure that I'm not the guy that says I don't like olives because I didn't like them when I was a kid. And I'll eat an olive every year and be like, this still sucks. I hate olives. But I have data every year empirically that says I don't like olives. And I'll do the same thing with Windows containers. I'm not going to bash it. And so I know someone released a book recently on Windows containers. I'm going to buy that book. I'm going to read that book and make sure that I'm doing the right things as a technologist to study it. So, but my experience with containers is what I described, right? Like, man, Anthony doesn't like olives. And like the audience just got thinner. Like 20 people just left.
Anthony, let me just tell you something. You are hitting hot buttons. My wife loves olives. I'm in the minority. I do not love olives.
Right. But I love olive oil though.
But same here. And I gotta say, every now and then I come back and I'm like, let me see if my tastes have changed. And damn, they never change. But I do take a shot at it. And it's interesting to see in the chat now we're getting the pro and anti-olive camps set up.
Someone's got to tweet that out. All right, let's get back in. So Windows containers, just your mileage may vary, and so I don't want to disparage the technology, but there's a reason why. Hold on, I'll get to that later. I'll put a pin in that. We'll get to that a little bit. So the container universe, I think that is the cutest logo in all of IT. It's the Docker whale, right? It's got, I think his name's Moby. He's got some containers in there. So Docker is available on Linux, Windows, and Mac. Not so much a dirty little secret. If you run Linux containers on Linux, it's basically straight process virtualization. You don't have any virtualization overhead. If you're running Linux containers on Windows or Linux containers on Mac, you basically have a small virtual machine that's supporting you and providing you a Linux kernel to run your applications. Now, if you run Windows containers on Windows, then it's just Windows, right? And then you can run, and I covered Linux containers on Windows. There's a small Hyper-V VM that supports that. So Docker is tech, right? There's a company called Docker, though, too, that open sourced the tech and made that available to everyone. The container runtime, the thing that actually runs the container, has been open sourced, and Docker, the company, now provides tooling to make containers. And so really there was a lot of like things changing in 2016, 17, and 18, and it all kind of finally flattened out and standardized in a couple of ways. And Docker contributed a lot to that. And they still make great tooling. And I predominantly use Docker. But there are other container runtimes or container engines. Rocket Core OS, we talked about Windows. If you're old like me, you might remember what's called a Chroot jail from FreeBSD. Similar in concept. You basically take a process, you put it in a corner, you give it a file system to have access to, and that's effectively what a container does. And we'll get into that a little bit. But that's kind of the container universe. Docker is effectively tech. Docker Inc. is a company. You'll see things like Podman now are out there. And it's a really, really kind of cool evolving universe. But in the end, running a container is going to get you the ability to package up an application and share it. And that's what we're going to talk about now. So container images is the thing that we exchange, right? Inside a container image is going to be my binaries, libraries, runtimes, whatever I need to run my app, environment variables, and things like that. And it's going to be zipped up, and I can exchange it with you, right? You might have heard the term Docker pull. That's what you're pulling, is you're pulling an image. You're going to, registries are where images live, right? So that's how we could exchange an image. So if I do like a Docker pull from a Microsoft registry, well, I'm going to pull a resource from them, or I'm going to pull something from Docker Hub. And so that's where images can be exchanged, right? You can have private repositories, you have public repositories. You know, most of the ones, or all the ones that we're going to work with today, are public repositories. A private repository effectively just means you have to authenticate. You can run repositories on-prem, you can run them in the cloud, like an Azure or Azure Container Registry. It's just really a place to put data and exchange data. A Docker file defines what goes into a container image. And we're going to look at a pretty advanced Docker file later at the end of today's session when we look at, I don't want to let the cat out of the bag yet, but we're going to look at an advanced Docker file at the end of today's session. So you can see how a container is actually built. And so the process looks like this, right? If I want to make a container image to exchange with somebody, especially like a developer, you're going to write a Docker file. And a Docker file is just a set of instructions to do some stuff. And we'll look at the one later it's going to have a couple apt commands. It's going to install PowerShell. That's just the bash scripting effectively to define how to install some packages inside this Docker file thing. And when I do that, and I do what's called a Docker build, it's going to execute all those commands and make a binary thing that's available on my laptop now. And I can run containers from that on my laptop. There's not a lot of value in me just running it on my laptop, so I can take that container and I can share it with you by pushing it into a registry. So that's a way that we can exchange that container image. So this application that I might build that you might want to have access to, I can then make it publicly available to you or privately available to you to authenticate from a registry. And so we'll pull that image. And once you pull that image, you're going to pull that onto some host operating system, whether it's a physical or virtual machine. And I can then run that app exactly as you had it on your machine. All the binaries, libraries, and whatever that goes into that container image will be available to me. And one of the things that containers directly attack is dependency management. So, you know, you probably remember the days where you had, you know, this web application on that server over there, or virtual machine over there, and this web application on that one over there because they had conflicting libraries, right? That entirely goes away inside of containers. I can have completely conflicting libraries run in separate containers, consuming the resources of the underlying operating system because they're going to be completely isolated from each other. So that directly attacks that dependency problem that we might have had to experience before and have dedicated systems to deal with that. And so that's kind of the big picture about the workflow of containers. So this kind of from left to right here, this is kind of the process that kind of you'll go through over and over and over again. And this can be automated. You might have heard the term like build pipelines and things like that. This process is, you know, can be manual, but chances are you're going to make this an automated process. And in the end, it's going to pop out of, you know, your CI/CD pipeline is going to be the container image that you're going to run somewhere, right? And so let's shift topics to data persistency for a few minutes. So if I start up a container and it's running and I need to store some data, well, where's that data going to be stored, right? Because containers are ephemeral. If I delete that container image and it goes away, excuse me, if I delete that container and it goes away, what happens? Where does that thing go? So let's look at that in some pretty gory detail. So a container image itself is only read-only, right? And so if I go and I pull that container image down and I start that container on an operating system, it's going to take the read-only part of the container image and make this thing called a writable layer. And that writable layer is going to hold the data that changes inside of that container. But if I delete that container, right, that's going to delete the data that's in that writable layer too, right? So really, you could just never delete your container. But then that's kind of antithetical to like being able to service my application. I want to go delete my application and replace it with a new version of my app and still have access to my data. And so Docker, we're going to focus on Docker today. Docker data volumes are a way to give you the ability to decouple data and computation. And so what a Docker data volume will do is it will give you access to basically a file system location on the underlying OS that you can take that container and any data that you write into a particular file system location will go into that volume, which means I can take that application, throw it away, start up a new version of my app, and it's going to look at that volume again and see its data there and go. Right. And so that idea of decoupling data and computation is extremely valuable because now I can service my application completely independent of my data. Now, in this scenario here, you see volume 1 is on the physical machine. That, of course, can be in a storage network. That could be, in some sort of other block device file system and things like that. There's a bajillion different ways that we can access, a container can access data. And so I have a link to the docs at Docker. It's one of the longer articles on docs for Docker. It describes all the different ways that you can store data and access data inside of a container. Super fun stuff there. And so let's talk about running PowerShell in containers, right? So when Snover and the team did the whole PowerShell core thing, right? What was the vision for PowerShell core, right? They wanted to be able to run PowerShell anywhere, right? And everywhere, right? Whether it's on an IoT device, whether it's on Linux boxes, wherever. That was the goal, was to make it, be able to run that effectively independent of the architecture, right? And so what if we wanted to run a particular version of PowerShell, right? Maybe I need to run 2 different versions of PowerShell because I wrote some code that was dependent on something and I didn't want to deal with that, right? And refactor the code, we could do that. We kind of learned about how we can run, conflicting versions of apps. And so imagine running 2 completely independent versions of PowerShell on the same system, right? And building that to run whatever thing that you need to do, or test. Right, if you're making a module and you want to test against different versions of PowerShell, imagine that was a little bit challenging to have to do before. Maybe you had multiple virtual machines or something like that, maybe multiplex between that. PowerShell core attacked that problem a little bit with how it decoupled those things and put them into file folders, but you're going to see how easy it is to run multiple versions of PowerShell here in a few minutes. So yeah, we're going to run wherever we want as a container. And so one of the things that's neat with containers is if we can inject scripts. So if I want to run a job, to do a thing, to run some code, I can do that. I can pull a PowerShell container, I can inject a script, I can run that script and it goes away, right? The container itself goes away. And all evidence of that run actually went away too. In fact, I remember doing this presentation at 2019 and Ashley McGlone was in the audience. I just sat through, he did a 4-hour workshop on like auditing and security and things like that and how to build good secure infrastructures. And I made this statement. I was like, what if I wanted to run a script in a container and it just goes away when it's done? He was like, man, right? Because you're concerned, like, how am I going to audit that? How am I going to save, like, how am I going to protect environments from that? Like, if I could just run a script and have all of the evidence of that execution just gone, right? And so I have to make the joke, like this idea to be able to run code and then just have the thing go away sounds like serverless, right? And so we're going to look at that jokingly. We're going to build a function as a service platform in our demos here in a few minutes. What about job distribution? Like, how am I going to go and do a lot of this work? Like, how do I get into a data center? I'm not going to go and like run containers manually to do this kind of stuff. And so that's where container orchestrators come in. We'll talk about that towards the end of today's session. So job distribution, I don't think is a solved problem, but there are tools and techniques to help us to be able to, if I need to run this container and that script and do it 10 times to add some concurrency to an application, there are tools and techniques to do that with what are called container orchestrators. And I think I touched on testing already. So we can run, obviously, test our code and then develop code. So that's our big things there. So I'm going to let the cat out of the bag on one of the things that we're going to look at, Cloud Shell. If you run Cloud Shell, that's a container, right? So if you're working in Azure and you hit the little Cloud Shell button at the bottom of the screen, that's a container. But what you might not have known is that container is publicly available to you to run wherever you want. And so today, we're going to go through that. We're going to look at Cloud Shell. We're going to look at how I can run that, log into Azure, and do the things that I would do just without having to install a single tool. I just did Docker pull Cloud Shell. It's a little more syntax than that, but effectively, Docker pull Cloud Shell, Docker run Cloud Shell. I have all of those tools where I need them, right? Pretty cool stuff. And so I have some links to GitHub for that. I'll jump back to that other link here in a second. There's one, I was going to go through some code, but we'll come back to that.
So one of the takeaways here, though, I'm seeing is the image that you're pulling down for the container is good enough. It's not this thing where, I'm a Windows guy, where the base OS that you install from Windows needs to be massaged and tweaked to get it the way you want it to be to run in your environment. In this case, the image you get for the container is basically ready to go. You just need to put your app in there or maybe data.
Yep. Yeah.
Wow.
And in one of the common techniques to inject configuration is environment variables. So we're going to look at environment variables in a few minutes. So that gives you the way to decouple configuration. So you're pulling out both your state, your application state, by putting that into volumes, and then you can factor out your configuration. So that thing even becomes less sticky, right? Because then I can store my config external to my application, which becomes a super valuable idea.
And these container images are probably vendor images that are released, I would assume, right? That's the idea.
Yeah, kind of. It depends on the tech. So let's look at a couple of things here. I'm going to bring up.
And where I was going with that is that there's some sort of trust process already built in that the image that you're getting, the container, there's a quality to that container that you don't have to worry about the reliability or the quality or the goodness of that container. At some point, you have stuff that you use, and you just rely on that container and the company or the service that builds and maintains that.
Yeah, there's a whole. This is the rabbit hole. But you're right. You're putting a lot of trust in who you're consuming containers from, because you're literally running their code in your data center, and you're pulling it from their container registry and running it in your data center. And so there's a whole bunch of layers of security practices that we can dive into. So for example, like some people that I've worked with won't use the public SQL Server container image. They'll build their own and then use that and store that in their own repositories. And so that's, because they don't want to run someone else's code that, or potentially someone else's image that was built, because you're starting a process in your secure environment potentially that you probably can't really track the lineage of. There's a bunch of stuff around, we'll get into it a little bit when we get into the demos, around hashing and things like that. So there are guarantees that what the publisher of the container image pushed into the registry is what gets delivered to you, right? There's guarantees around that because of hashing on both what's called the manifest and then the image itself, right? The description of the image and then the actual binary image, right?
So I get all that, and there's a lot of minutia involved around that, and we can obviously, like you said, can get into it. But the thought process here is that the image or the container that you grab, without going into lots of particulars, should be a production-ready thing that's ready to go, and you sort of have a confidence in the file that you're grabbing is what you need, and you're off to the races.
Yeah, I remember having a debate with a lot of folks about this, because in the end, regardless of how you're distributing code, you're trusting someone else's code. If I'm running a Windows installer, if I'm regardless of how I'm getting code, I'm trusting that code was built properly and that code wasn't, doesn't have anything injected to it, SolarWinds, like that could potentially compromise my environment, right? And so that's a lot of trust in enterprise IT. This is the gold standard for container security. It's a book by Liz Rice. It's from O'Reilly. I've read this book 2 or 3 times. It talks all about these concepts. It's the way to go, and it's super deep dive tech, but explained in a super elegant way that's consumable. So I highly recommend that book if you want to get into that topic in gory detail. So fun stuff there, though. But let's look at. Let me shelf this for now. Let's get back into. All right. So PowerShell, we kind of get the idea of like running PowerShell in containers. Kind of like gives us a lot of functionality with regards to developing modules, testing modules, potentially running concurrent jobs in environments, things like that. But why would I want to run SQL Server in containers? Well, kind of all the same reasons, because I can roll out things super duper quick, and I can write code to roll out things super duper quick. And so I can get deployments done faster. I get upgrades done more quickly. I can patch SQL Server more quickly. It all comes down to speed. Being able to get what I need done to provide value to my business a lot faster than I did before. And here we go. Windows and Linux containers are available for SQL Server. There's the link to the MS SQL Docker GitHub repo for Windows containers. But guess what? They used to be not in production. Now it's been to development of Windows containers. SQL Server is totally suspended. And so if you want to work with in fact, all of the images have been removed from a repository. You can still build your own, but Microsoft is not providing support on that, not production scenarios. And so like, in my mind, like the writing's kind of on the wall there, right? You can kind of see like, that's interesting that, one of the largest product groups inside of Microsoft isn't getting behind running SQL Server on Windows and containers. That's a really interesting topic to think, like dive into. We're done with the presentation. It's time for code. And so we're going to do a bunch of stuff. We're going to pull images. We're going to run containers. We're going to show you how to access applications, connect into a container, kind of look around a little bit. We're going to look at persisting data. We're going to talk about injecting commands into containers and scripts. So that kind of like the core techniques for the PowerShell folks. And like I joked about during the presentation, we're going to build our own serverless function as a service platform using containers. So, cool. All right. So I'll make the deck available to everyone and the code. I'll put this on GitHub. It's about 8:16 my time, so probably in the morning. I don't want to go downstairs, eat some dinner. But definitely I'll have all of this stuff. The only thing that you need to run this on your workstation is Docker, right? And I have some links at the end of the deck on how to install Docker on Windows. Next, finish. On Mac, you drag a little whale into your app folder and go. I mean, it's pretty rock solid stuff there. So when you do install Docker, you get the Docker command on your machine. And so Docker is, like I said, it's just tooling, right? Docker is the thing for me to build and start containers. And we're going to jump into that process. When I talked about that kind of that build pipeline, we're going to jump in the middle, right? We're not going to build our own container data. We're just going to pull a container from Microsoft. And so we're going to pull from a container registry, the Microsoft container registry, mcr.microsoft.com. And so this is what's called a repository. That's the /MSSQL/server. That's where container images are stored. And container images have what are called tags. And it's a way to kind of version control the individual containers that I want to work with. So you see, this one's very specific. I'm going to run SQL Server 2019, CU13. That's an Ubuntu base image on Ubuntu 18.04. Right? And there's probably tens or dozens, at least dozens of container images. They're going to have one for each CU. They're going to have one for each supported version of Windows, so 2017 and 19. There's some RHEL containers out there. There's some Ubuntu 16 containers out there. And so you can kind of see how you can slice and dice the version control of exactly what you need for the platform. And so to bring a container image down to a workstation, right, Docker pull. You define the container image that you want. I pulled the container image before the presentation because I didn't want you to have to sit down and watch me transfer 1.5 GB of data from between two places. And so you can see the container image is up to date for that. Here we see a digest, right? That's a hash of the thing that was exchanged. So I know that this thing that I just pulled down matches that hash. It's what Microsoft put there, right? So I have the container image on this machine now. In fact, I have a bunch of container images on this machine now. I cleaned them up before the presentation today. Cleaned them up yesterday for the presentation today. And kind of limit it down to things that I thought would be interesting for tonight. I have a bunch of PowerShell containers in here, which we'll talk about momentarily. I have a couple SQL Server containers here. So there's CU13, there's a 2017 CU26, 2019 CU12. And so I have all of these things available to me on my local operating system here. So I can very quickly test and run and do whatever I want with all of these images or any of the images that are available from any container. So that you can kind of see the power and how that unfolds there.
Question from the audience. Is there a PowerShell module for Docker?
PowerShell module for Docker. I don't know if there's like a Microsoft PowerShell module for Docker. I do know Docker commands emit JSON. And so I know there's been some work to like kind of connect the dots there. So that might be an easy way for you to get some automation around that.
So we have Mr. Glenn Sardi as a guest tonight, and he chimed in and said there was, but it's been deprecated and abandoned. So apparently didn't make it too far.
Yeah.
And thank you, Glenn, for chiming in.
Yeah, appreciate that. Thank you, Glenn. Thanks, Glenn. But you can see, right, this is pretty crazy. Like I can guarantee you that the smallest SQL server in your environment is not 1.5 GB. I think the smallest SQL server in a Windows environment is going to be about 60 gigs at a minimum, right? Just to put the base OS and SQL Server on there. And they're like, man, I need to expand that volume a little bit, right? And so that's a huge difference in how to support service and application. Look at the PowerShell container. It's just a couple hundred megs. I run Pi-hole on my laptop here to filter out DNS, or use DNS filtering to filter out ads. If you don't know what Pi-hole is, you're permitted to leave this presentation right now and go look at Pi-hole, because it basically will filter out all advertising and tracking from your network. And that's 300 megs, 330 megs to get that, right? That's a pretty, again, crazy piece of functionality in a very small amount of code. And so let's get to the point where we're going to run a container. Docker run, right? Now I talked about decoupling configuration. And you can inject configuration with environment variables. And so these are two environment variables that I need to start up this type of container. As you build containers and get more sophisticated, you can decide like how you want to configure your apps. And usually developers will expose things this way. There's some other advanced techniques that we can talk about with injecting configuration files, but we'll shelf that for another day. So there's the two things that Microsoft says that I need to run. I need to accept the EULA, of course, and I have to inject a password for SQL Server to get started up. It's something so strong. You're like Crowded House.
I was going to ask you if that was the reference.
Yeah.
Dating both of ourselves there.
So now I'm going to run my application on a port. There's this concept of inside the container and outside the container. We'll get into that momentarily, but we basically, SQL Server inside of the container will always run on 1433 inside of the container. And obviously I want to be able to run multiple containers on an individual system here. So I need a way to kind of switch that. And so Docker gives us the ability to define what port we want to listen to on outside of the container. We'll see that kind of come together in a few minutes. Since SQL Server is a daemon, I'm going to, D is short for detach. And so basically it'll start the process up and background that task and give me my terminal back at the bottom. And this is the container that I want to run right here. So this is how we run a container. I just deployed SQL Server in like what? 4 lines of code. And super quickly. And so that container is now up and running. All right. So here we can see the image that's up and running. It gets a unique container ID that's generated automatically when the container starts up. The command that is executed when the container starts up, that's this. Been up for 7 seconds. It was, created 7 seconds ago and has been up for 5 seconds. That's the difference between creating a container and starting and stopping the container. We'll look at that in more detail in a second. It kind of wraps a little funny here, but I'm listening on all IPs on port 1433, and I'm sending traffic into the container on 1433. And then there's my Pi-hole container. And so with that, I should be able to access my application. And so right now, I'm just going to use a regular old SQL Server utility to access that container. So I'm using SQLcmd, which is a command line way to interact with SQL Server. And I'm just going to send in a simple query that says, hey, give me your name. Right. And you can see back, I get the host name, which also matches the container ID by default. Now, if I want to do that again, I want to run another container, I'll just do it again. I run another container. I need to give it a unique name and a unique port because I need to send traffic to this other instance. And now I have 2 instances of SQL Server up and running on my laptop, right? 1, 2. So there is SQL 2, and SQL 1. Yeah, it's kind of wrapping a little bit funny, but there are the 2 unique containers. And I can continue to do this with different versions of SQL Server, with different applications, whatever it is that I want to do. Here I can access that other container. It's just running on a different port. That's it. 1434 this time, but it's sending traffic into the container on 1433, right? So that's how Docker, the runtime itself, manages that translation. And so that way, from a developer standpoint, I just pin it to 1433 or 80 for my web app, and then I can run dozens of those on a single system without having to deal with the port conflicts that I would have to deal with if I didn't have containers. So let's get some data into a container. This is going to use the command docker cp to copy a backup file into the container SQL1 at this file system location. Let's run that code. That literally is a binary transfer. And if I want to do a restore, then I can do that. And all I'm doing here is SQLcmd. This is a restore file that just has the restore gymnastics of restoring a database. And so I have a database now restored inside of that container and is available to my users to use now, right? Test DB1, super advanced stuff, right? And with that, you can, and I have a bunch of code online to build automations around that. So I could build a container, run a container, deploy the container, and then automatically kick off that restore script, right? And then I can start getting more advanced scenarios. Maybe I need to test different database schemas against different versions of SQL Server, things like that. It's to be pretty cool. So let's connect inside of a container, right? A container is running a process. That process is isolated on my operating system, but I can go inside that container and do some stuff. And I can use the command docker exec, do that. And I'm going to docker exec bin bash. And what that's going to do is give me a shell into the container. So there we see MSSQL at the host name. And so I'm literally inside the container. If I do a ps minus aux, which is a way for me to list all the processes that are running inside of the container, there's just 4, right? But there's certainly more than 4 processes running on my underlying OS, right? But due to the way that containers operate and provide isolation, SQL Server just thinks it's got, you know, the whole thing, the whole show to itself. And any application that's inside of a container will have that view of the world. And so there's a separate memory space, there's a separate file system space, and that's how you can attack that problem of dependencies that we talked about in the presentation. Like, you know, I can run completely conflicting things concurrently on an individual OS inside of a container. Now look at the file system. There you see the backup file that I just copied in, and then when I restored it, it created the MDF and LDF associated with that for SQL Server. So if I want to stop a container, so that's going to send a signal to the process to shut down gracefully. Sometimes it takes a second. That's going to stop the container, but the container is still on my system. I stopped SQL 2. SQL 1 still certainly up and running. I didn't touch that. But you don't see SQL 1 or SQL 2 in this list. If I do a docker ps minus a, this time it's going to be CU222. Where's 2? I stopped 2. Why can't I see 2? There's 2. Exit 0. It's a quality exit code 0, 18 seconds ago. But that container is still there, so I can start it back up, right? So it's just going to restart the process. My data is still going to be there, all of that fun stuff. And so they, you know, that's kind of the life cycle of a container in that I could start it and stop it. Then I can go and come later and I can delete it. So let's go ahead and look at that. So right now my data is still in that container. That test DB is still there. I can stop my containers and they're still there. I could restart them if I need it. So there's SQL 1 and SQL 2 in the listing of Docker PS. But if I remove the container, the database that was in that container is gone now. It's in that writable layer. The image was read-only. The image started up. Anything that was changed inside of that running container is stored in the writable layer. They're brought together and presented to the application in a unified way. When I delete that container, the writable layer goes away too, right? The image is still there, so I can instantiate more containers from that image, right? I was using the CU13 image here. But right now, it's just my Pi-hole container that's running. Like, so that is completely gone. So let's look at how we can kind of decouple now, not only configuration, but also state for my application. So I'm going to run another container now, but I'm going to add additional parameter -v SQL data 1, and then var opt MSSQL. What this is going to do is allocate storage from the underlying file system inside the OS and mount it at that location, var opt MSSQL. So just that location is going to be back-ended by the storage. Anything else that's changing inside of the container is going to go into the writable layer. But anything that's in var opt MSSQL will now persist independent of the lifecycle of the container. So let's go ahead and see that in action. So same exact container, CU13. I'm going to start that up. I'm going to copy a container into the, so I'm going to copy the database in again. I'm going to do the restore script again. Everything is good. Restore successful. I'm going to show you that my database is definitely there. I'm just getting a listing of the databases that are available. So those are the 4 system databases and a database that we just restored. If I stop the container and remove this container, and then I start it back up again, but this time I point it to the same data location, what we're going to see is, in a second, it takes a second for SQL Server to start up. So you can see I'm getting some errors. Pre-login failure just means the instance isn't started yet. You can see my data's there. Whereas in the previous demo, when I deleted the container, my databases are in a writable layer. Now my databases are in SQL Data 1 which is a Docker managed volume that's allocating storage from the local file system. There's some. Oh, go ahead.
No, I didn't mean to cut you off. I was just going to say that the loss of data is associated with the throwing away of the container, not a shutdown and a restart. That's whatever's inside that container remains on a shutdown and a start, but it's the removing of a container and reinstantiating it.
Yeah, that writable layer is what gets tossed when you remove a container. The image stays. Yeah, the image stays, and we can reuse them over and over again. So let's see where that volume actually is. So we can use Docker volume inspect. This is like my favorite Docker command because it gives you like the gory details about a thing, whether it's a container, an image, and whatnot. So the driver is local, so it's being allocated from the local file system. The mount point, this is where that data physically sits on the base operating system, but it's up to the container runtime to present it at this location. And so if I did a directory listing here, I would see all the databases that were associated with this particular volume that I attached, right? That's named SQL Data 1. Full disclosure, there's some shenanigans occurring because I'm on a Mac. Remember I told you there's a small virtual machine that supports Linux VMs running on Mac and Windows. If I did this on a base Linux system where there's no virtualization layer involved, it would be literally, you could see it, the files there. So it's pretty cool to see that in action. Sorry, bubbly water. All right, so let's see. We did inspect, stop our container, move the container. So this is where we get rid of the writable layer. And then the volume is still there, right? So Docker volume ls. The data is still there. I have two other volumes for whatever reason. And now if I do this, that will reclaim that storage. And this is when the data actually goes away. Sad face, right? And so that's kind of like, this is how I got started with containers. It's a fantastic way like to kind of dive in, and I think to demonstrate the concepts of image, start, stop, and Mike, you connect the dots with regards to where data physically lives and things like that. But, you know, let's look at this, what we can do with PowerShell, right? And spend some time doing some demos here in that universe. Now, I do want to show you, let me see, Docker Hub Shell. So most of these images are going to be available on Microsoft's container registry, but the list of container images is what's called syndicated to Docker Hub, and the user interface is just a little nicer. But these are all the Windows images that are available to run PowerShell. So you see a bunch of Nano, Windows Server Core. So this might answer some of the questions you guys had about Windows environments. But look at all the various iterations of different things for different images, different versions of PowerShell, you know, preview versions of PowerShell on different platforms. And then that's just on the Windows side of the house. That's like, you know, probably 100, 200. And then on the Linux side of the house, you know, I have CentOS, I have ARM, I have Debian. And so it gets to be pretty complex in what you want to consume and use. And so these are all available to build from. And so these things here that I keep referencing are tags, right? And that's what I have over here on the right. So the registry, the repo, the tag, 715 Ubuntu 1804, right? And so if I go here, jump back here, do a quick find, you'll see that's where I got that from. But you can take a peek at actually how the image was built. I told you there was a Docker file that builds the thing. So this is what Microsoft used to build this image. It had a Docker build, and then it goes through and it runs these commands. So Mike, you're talking about like trusting things. So the image, the base image is Ubuntu 1804 is published by Ubuntu. So Microsoft's trusting that Ubuntu's image is good, right? And then you go from there and you kind of build up and you kind of see how a container is built. It's just a sequence of commands to put the application into the container. And then I do the Docker build that runs these commands. And then I have the thing that we can exchange. And that's literally what this is now. That's a binary representation of the actions that have occurred inside of this Docker file, right? So I've pulled all of these containers down previously, so I can run this again, just so you don't have to sit through me pulling a couple hundred megs of stuff. But, oh, Z shell, I forgot. This is on Z shell now. I have to do one at a time. So like I said, Docker inspect is my favorite command. Let's do a Docker inspect on the PowerShell latest container and pipe that output into less. So I told you pretty much Docker loves JSON. So here we are, right? So we have the tags associated with the image. We have the digest of that's presented from the repository. So that's a hash of the container image. We have some configuration with regards to how the container is started up. So attach standard in and standard out. That's all set to false, and I'll show you how to override that so we can get an interactive terminal with the process. We have injected environment variables. So Microsoft has chosen to inject some of these variables here, right? Some of those might be familiar to you. And then this is the command that's actually started when the container starts up. So it starts a shell with the parameter C, but then it just launches PowerShell. And so you'll get that inside of your terminal. So Docker run, we're going to give it a name. I have two parameters here. I used -d in the last demo to detach. We're doing the exact opposite now. -d detached and put SQL Server in the background as a process. We're doing the exact opposite now and asking for an interactive terminal against the PowerShell latest container. So I'm going to run this, and I have PowerShell. Let's see what version of PowerShell. I have 7.1.5, right? So now I can go and test whatever I want on 7.1.5. I need to bump up to preview 7.2. I can do that too. Let's look at process. There's a single process now. SQL Server had a couple processes running in there. That's due to the architecture of SQL Server and how it does things. But you can see that I have certainly more than one process running on my base OS, but PowerShell C is just itself, right? Let's run a quick command. You can see that I have a file now inside the container, whereas I didn't have that before. And I can exit that container. Now, comparing this to what we saw a minute ago, right? When I started up my container, SQL Server, it was background and detached. When I exited this process, that actually terminated the PowerShell process. So that PowerShell container stops. It doesn't stay up like it does in the SQL Server side of the house because we told it to detach and stay up and running. PowerShell, when I exit the PowerShell process, it just shuts down gracefully. So here we see that our status is exited 0 about 20 seconds ago when I did a listing of all of the containers regardless of their state. But I can restart that container with Docker start. I pass in the name that I want to start, and I do -i, which is a short version of the -- interactive parameter that we saw a second ago. And there we can see that this is in the writable layer that we described, right? I have the text that we wrote out a few minutes ago, and that's available inside the writable layer of the container. But when I delete it, that goes away, right? Darn Z shell. Yeah, so now that container is gone. And so that kind of life cycle in PowerShell is slightly different than what we saw when we were running a daemon, right? Because once I exit, things just stop versus staying up. And now that gives us the ability to do some pretty neat stuff because now I don't have to get an interactive terminal. I can start injecting commands, right? So Docker run PowerShell latest. I'm going to run PowerShell -c, and I'm going to inject something to get processed. So now I don't have to go into the container to do anything. I can feed it work. Right? So I can feed it work externally and just do this thing. Give me a process listing, run this script, right? Run this commandlet. And then I can do that against various versions, right? I can do that against the latest version, which gets me a 7.1.5 container, or I can do it against an older version, right? I want to maybe there's a functionality change in all of the historical development of get process, right? And so there we can see I have the ability to run arbitrarily against any different type of container. Let's do that against the preview version of Ubuntu, this time just a slightly different command, get host. And so there we can see I have 7.2 as I'm running against the preview version on the 1804 PowerShell. And so we get that flexibility of being able to just run code arbitrarily against different versions of PowerShell, regardless of if PowerShell is even installed on the system. I think it is actually installed on my laptop. 7.1.3. So it doesn't even match any of the ones we've been testing, but this all exists and coexists happily on my laptop here. But all of those containers that we were working with, they kind of left some stuff around, right? Because I wasn't deleting the container after we were done. So there we can see all the executions that we were going through. And If I want to delete those, I can kind of build a nice pipeline like this, get a listing of all the stop containers that have the name PowerShell in that, grab off the container ID, and then delete all the containers. And that way I can kind of quickly clean up from this demo. And you can see all 3 of those containers went away. Cool. So let's check out how to run scripts now. And so there's a couple different techniques that we can do. I'm using the Docker data volume technique. We'll talk about bind mounts momentarily. And so if I want to get some data into a volume, that's what we're going to do first here. Is I'm going to start up a container and detach it. This container literally started and stopped. And you're like, why did you do that? Because I wanted to create the volume. And then I'm going to copy a PowerShell script into that volume that we just created inside of that container. There's a bunch of different ways to fry this fish, but this is the way that I chose to do it for this demonstration. I could also, rather than attach a Docker data volume, I could bind mount the exact directory that I'm in. So these scripts that would be, or any directory really, would be available inside of there, but I'd like to use Docker data volumes because I think it's a cleaner abstraction. So where were we? All right, so I removed the container. What we're left is with a volume that contains all of my scripts, right? And so now when I run a container, Docker run, just PowerShell script, I'm going to get an interactive terminal this time. I'm going to reuse that volume, and I'm going to run a 715 Ubuntu container. So inside of here is my scripts. And so I can then go ahead and run that code to do what I want to do, whatever it is that I want to do. And in fact, if I need to go and just pull from a repo, that's things I can do as well. I can pull code down, bind mount that in, and have access to those things in a very easy way. Pretty cool stuff there. Then remove that container. Darn it, I keep forgetting that I'm on Z shell now. Go away. There you go, PowerShell script. All right, so let's go even further. We saw when I would run a container and I'd inject something, I'd still have this remnant around that the container ran. Well, let's go even further and just tell Docker, once I'm done, just remove the container. So I can run that script that we were working with inside of our container. And so I'm going to Docker run. As soon as I'm done, I'm going to delete the fact that the container even did the thing. I'm going to attach the volume that we just built. And I'm going to use the 715. I'm going to execute this script, right? So now I can run code totally within that container, execute, return. And if I do a Docker PS minus now, all we'll see is my pie hole there. So the fact that that even occurred doesn't exist. Pretty crazy to think about that. So let's go ahead and clean that up. We'll get rid of all the containers. We'll get rid of the volume and go into our last demo where we'll look at Cloud Shell. So Cloud Shell, LS, is Titanic. 9.5 gigs, 9.3 gigs. But it's got literally all of the tooling you could possibly want for interacting with Azure. So you Docker run, and inside of here, if I do an AZ login, this is supposed to be AZ login. So I'm going to pop that into my clipboard, get that off camera. Even though I use a password manager and MFA, it's all good. So in a few moments later, I'll have access to the full suite of tools that would eventually be available to me in the Azure portal inside of Cloud Shell in a portal, but at the command line here. And so if I just want to do something silly like get a listing of virtual machine sizes, I can do that, right? So pretty cool stuff to be able to get these tools and exchange them with me, with you, or whomever very quickly. And if I want this, you can see an example here where I'm using the same container, Cloud Shell container, but I'm starting a different process. So IT is for interactive terminal, right? And what I'm doing here is I'm launching bash. And then I can come back later and launch PowerShell because they're both available to me inside of that container. In fact, let's go ahead and do that. Now, this is a new container that I'm starting because I'm doing a Docker run. I could have stopped this container and restarted that container with PowerShell, but I chose to just start a new container. And here I have Cloud Shell up and running, and I'm running PowerShell 713. So let's jump back and look at a pretty big Docker file. So Microsoft publishes the Docker file to create that image. And so you can see how more complex applications are built by examining this Docker file. This is the link that I skipped over in the presentation when I talked about Cloud Shell, and then there was one specific that I wanted to jump over. So you have available to find, or you'll have the link available to you in the presentation. And so you can kind of see how to build a more complex application here. Let's look for PowerShell. So this is how you install PowerShell inside of the Cloud Shell container, right? So basically get access to the repo, bring the package down, install the package, right? Or get the repo, install the repo, update, install the package. And so this is kind of core to how you build containers. Let's see, jump back to presentations. That's a wrap for the demos. Like I said, I'll make the code available to everybody. Let's jump back to the presentation and wrap things up. Skip over that. So one thing that we haven't really dove into is this concept of container orchestration. The big idea behind container orchestration is really, given a collection of compute resources in a data center, where do I run this stuff? Or if I want to run 10 copies of a PowerShell script or 10 different SQL servers, where do I run that in the data center, given the resources that might be needed to run that application? And that's really what a container orchestrator does, is it figures out where to run a container inside of a collection of compute resources in a data center or cloud. It also manages the state, so starting things up and keeping them up, right? We kind of have this concept of desired state inside of container orchestrations. I think about desired state, but you told me it was stateless and or ephemeral and all this stuff. This is true, right? So that's kind of the key behind decoupling configuration from state, because now a container orchestrator can delete that container and replace it with either a new version, or if there was a failure, and put a new one back. And my configuration's external, my state's external. I can just restart that container, config, state, and I'm back, right? That's one of the key things that having those things being decoupled from the application provides a lot of value to. We can provide networking and load balancing for access to the containers, persistent storage, and this idea of a declarative model, right? So those concepts behind DSC of writing the code that describes what you want. In container orchestrators, you can do that. You write code that describes what you want, and the container orchestrator does that for you. And then job distribution is another big one for scheduling workload. Most common thing that I've seen for job distribution is in Azure Arc-enabled data services running things like backups, right? And then that's kind of a way to just go and do some work, right? And so it really can be any type of work: PowerShell, database backups, scripts that need to run periodically. Secrets and certificate management get pushed into your container image or into your container orchestrator, or using things like Azure Key Vault and things like that to work with that. Some of the big container orchestrators are out there. The big one is Kubernetes. It won the container wars. Red Hat OpenShift is effectively a for-sale version of Kubernetes, supported by Red Hat, VMware Tanzu, and then the managed service providers are all different ways to get Kubernetes. If you want to just kick the tires on Kubernetes, you're about 3 mouse clicks away from Kubernetes if you've installed Docker. You go here, go to Preferences. Came up on the wrong screen. You click here, you check this box, you'll have a Kubernetes cluster in about 10 minutes to play with on your laptop, which is pretty cool. Let's see.
That's crazy.
Yeah, it's really neat. There's even better, I would say even better ways, but it's really expanding, because the idea is to give folks the ability to run and develop locally against Kubernetes and consume those resources. But that's a wrap, right? I think we kind of introduced containers. We looked at various application scenarios kind of in the Windows universe, historically Windows universe, because now everything's on Linux. We looked at just the different things that look around at what containers are out there. We looked at lots and lots of demos, container orchestration, things like that. So I'm going to leave my contact info up just kind of open it up for Q&A for everybody and kind of jam out a little bit.
So first off, let me say thank you so much for sharing. That's very interesting. And no matter how many times I've seen these demos, it's very hard to wrap my head around the speed at which environments could be stood up, taken down, and reinstituted. It's just not something I am associated with in the Windows world and managing OSs, even VMs and things like that. It's just, I don't know, it just seems so foreign to me. But there was some questions I saw in the chat earlier about just various stuff, and someone was wondering, like, how does this whole concept of containers and the way that it works, how does this fit with organizations that have a high security model and audits and all that stuff? I mean, do you find organizations understand this and they can get behind it, or this is, oh my God, I've never seen this before. What is this crazy technology? We don't want to do this here. You know, to me, it's I know you have something you want to say, but I was thinking, like, it's config is scripted, data is separated, data is secured. However, I would think that this would lend itself very much to security and audits, because it's a very predefined thing. It's not Mike went and configured the image the way he wants to do it. It's, we ran a script, we pulled down an image, the image is baked, our data sits here, we secure the data this way. It seems like it checks the security boxes that people want, but maybe I don't know. What's sort of your thoughts in that arena?
So one of the things that changes with containers is where logging and audit data is stored. Like, we're so used to having logging and audit data as part of the operating system, and we go get it there, right? And so I think Steve Judd makes the comment, he's like, you basically have to make that part of your application now. So you need to emit logs, you need to emit audit streams and things like that. And there's a whole tooling universe built around collecting and unifying that stuff, that provides what we would normally expect from the base OS, right? And so things, I'm drawing a blank on the name, Kibana, right, is a tool that gives me the ability to look at a collection of logs that have been aggregated together into any of the various log aggregators that are available to go and look at log, right? And there's a similar platforms for audit. And that's why things like OpenShift, Elk Stack, that's why things like OpenShift have become a thing, because then it's, if I'm a regulated industry, I have a vendor that is providing me a platform that is constructed like this and can provide, like, the defined audit streams for me to work with. And so that's why I usually make the joke when I'm talking about the different container orchestrators. You can just run Kubernetes, right? It's open source, yada yada. But if you're the kind of org that needs audit and support contracts, you're going to look at Tanzu, you're going to look at OpenShift and all those players, right? So, and I absolutely think the number one reason why IBM bought Red Hat is to get OpenShift. So,
but there's a methodology there so that you can build in the security that people are looking for and make it fly with all the people that are concerned about different things. So that's really interesting. What I've often wondered about is, like, man, this looks so cool and looks really like, why wouldn't you do this? And so that's the question, is like, where does this not a good fit for something? Because I'm an AD admin. I've never seen domain controllers in containers, right? And then there's a reason for that. But so there's so that's the thing, right? So there's some things that don't fit with the container model, and what kinds of things would you stay away from the container model? And that's a little bit open-ended, but just thoughts.
It's because you would think like stateful applications, but you saw how elegant you can put a stateful application inside of Kubernetes or inside of a container, and then eventually in Kubernetes. I think you're right. I think it's kind of hard to wrap your head around. I definitely wouldn't do domain controllers, but like, I was going to make maybe infrastructure services, but that's not true. I'm running a DNS server right now on my laptop, right? So it's a hard question to ask. Like, where is it not? So
I get the sense, and I understand what you're saying, but I do get the sense, like, when virtualization came out, and I'll relate to my world, like, oh no, you can't run a domain controller virtualized. That's not supported, and then eventually it just is. Nothing really changed. It's just somebody somewhere goes, all right, we'll let people call and make support calls on that, right? It works. But so maybe it's just something that isn't well blessed yet, but is on its way to.
Yeah, I think that's the big thing is as the application architecture shift towards that, right? And I think if you look at, this is neat. This isn't a plug for my book, but I wrote a book last year on Azure Arc Enabled Data Services, and the program manager of that product, Travis Wright, tells the story of how they got from SQL Server on Windows to SQL Server in Azure Arc Enabled Kubernetes, right? And what they had to do was they had to figure out how to get SQL Server on Linux. They had to figure out how to get SQL Server into a container. They had to figure out how to get SQL Server into Kubernetes. And then boom, they had Azure Arc Enabled Data Services, right? And so that shift, right? They saw that I need to get my app into Kubernetes. That's what they wanted. And then they had to figure out how to make that journey happen. And it was like 5 years of some really cool engineering to make that happen. So yeah, so that depends on the app owner and if they want to invest in that shift, right?
So I'm sure from your point of view doing the demo, you're probably like, wow, this is going really well. There's no questions. There was a lot of activity in the chat. We have some smart people there that was sort of answering questions on your behalf.
Thanks,
so we
Steve.
didn't have a lot to funnel up to you to sort of hit you with. But yeah, there was Steve, you said you had a question, so bring it on. Feel free, anybody, and just I'll open it up to everybody. If anybody wants to ask questions, feel free to turn on your mics, turn on your camera. You know, if you want to throw it in chat, we're going to wrap up here soon. So if you have questions, let's get them in. But go ahead, Stephen, if you have a question.
Thanks, Mike. My question, Anthony, is in your work with SQL Server, people like they like their SQL servers to stay online. So if you're containerizing your SQL Server, what do you do in order to make it resilient from any issues with the container?
Can I come back next month and do my session on deploying SQL Server in Kubernetes?
That I can't answer.
Well,
Mike.
we'd love.
So
we'll definitely have you back if you would like to do more. That's for sure.
So if you want to do it in straight Docker, right? Docker run. There's a parameter called restart. This is just in straight Docker, right? I can say, I forget the parameters off the top of my head. Start. Yeah, I can't remember the parameters off the top of my head. Anyway, what the restart option will do is restart. If I reboot the computer, it'll just restart the container. If I've created the container with the restart parameter, and then there's restart. I forget, restart like on failure. So basically, if you get a non-zero exit code, it'll just restart the container, right? And the other option is just never. That's the default option, right? So within an individual operating system, if I want to just run a container all the time on a single OS, maybe even 5 containers in my data center, I can use Docker, just straight Docker to do that. Now, if you want to do it in an enterprise grade, that's where Kubernetes comes in. So if you want to build like a dev stack and have a SQL server that runs all the time, use the restart parameter, right? That'll get you around if the OS reboots. But if you want to do it for real production grade, that's where SQL Server on Kubernetes comes in. I wrote the book on that, literally. And so we, what a container orchestrator will do, and we talked about it during the presentation, is it has a couple jobs, right? Workload placement and managing state. And I use a declarative model, right? And so, well, the first one wasn't a book plug technically. It's just because Travis wrote the forward, and it was such an excellent forward because he describes that journey. And that was what Mike was asking. But so in Kubernetes, I have a declarative model that is in charge of workload placement, that's in charge of also managing state. And so I'm loving like getting ribbed on in the chat. Anyway, like I actually am. It's really funny. And so let me see. Please code. I have a drink request made downstairs. So in Kubernetes,
are you trying to show us something?
Yeah, I'm getting there. I'm like going.
He's prepping.
Okay, all right. I just want to make sure because I can't see anything yet.
Bang. All right. So I have a blog post. Yeah. you saw me do Docker run. No one's going to run around their data center doing Docker run in an enterprise grade. You're going to write code to do this thing. And so in Kubernetes, I have the way I can write code that describes what I want. And the Kubernetes cluster will go do that. And so I take this code, I give it to Kubernetes via an API, and it'll go and it'll download this container image, right? Container port. So these are things that we saw a few minutes ago. Container image, container port, accept EULA, SA password, attach a volume at a particular location. And so what Kubernetes will do is go and start that image, attach that volume, expose that port, and I'm describing what I want. Now this,
let me just jump in here.
Yep.
Are you on a different monitor? We're looking at your file system.
Oh,
yeah.
Right there, code.
There we go.
It's like a rookie mistake there, man.
It's late.
Right.
You're allowed one.
It is getting late. So this is all stuff we saw a few minutes ago. We'll zoom in on the middle of the code and kind of unpack it. I want to run this container image on this port with this environment variable, with that environment variable. I want to attach this storage at that location, right? So we saw all of this stuff a few minutes ago, just in a different format, right? And so I take all of this code and I give it to Kubernetes, and it'll go do that stuff, right? It'll go start this image, yada, yada. But I have it wrapped up in what's called a deployment object. And the deployment object maintains the state of what I want done here, of what I've defined here. And I'm saying I want to run exactly one copy of this application. And so I give this to Kubernetes, it starts this up and it runs this until I delete this object from the cluster. And so that's the way for me to be, if I want to do this in an enterprise grade fashion, always keep it up. And for example, if I have 5 nodes in my cluster and this application is running in one node of the cluster and it dies, it can move literally to another node in the cluster automatically, right? And so you can get failover cluster-like functionality out of this many lines of code inside of Kubernetes, right? There's some fine tuning on how fast that failover happens to make it tolerable for recovery objectives, but you pretty much get that for free inside of Kubernetes. And so that's a simple application. You get more complex as the whole microservices architectures and things like that. We start breaking applications down into smaller chunks. This becomes the only way to be able to do that kind of stuff. And so is to have code that describes what you want.
Yeah, I think the part where my mind starts tripping up on this is when you've got a container and you say, I want one version of this and keep it online, and here's my health checks, and what's running in my container is SQL Server. But somewhere I'm storing the transaction logs because I don't want to lose any data, but I'm also storing my actual database files somewhere else. It's the non-transitive, the persistent data part that my struggle comes when I'm dealing with containers.
So let's look at this. Bring that back up. Watch, I'm going to share the other screen now, right? So what we have here is, I kind of leave it out of this particular implementation, but I have this thing called a persistent volume claim. And we talked about the concept of container image and writable layer. And so when a container image or a container inside of Kubernetes is removed or stopped, it's actually deleted every single time. So that concept of start and stop doesn't exist inside of Kubernetes. So you have to do this. And so I put if you think about this logically, what I'm doing is I'm saying I want to put a disk right there. There's like a mount point. It's like imagine me just plugging a hard drive into var optimize SQL. That hard drive is being allocated by Kubernetes, and it's going to go get that storage from whatever I've designed to be the storage subsystem for my cluster. So on Azure, that's going to be Azure Disk or Azure Files. On-prem, that could be, fancy storage area network 1, 2, or 3, right? And this, where we start touching the storage, it gets to be a little sticky because it's hardware dependent. But the idea that I kind of want to bring home to you is I'm asking the cluster for storage, and I'm sticking a hard drive right there. And if this container dies, it's going to start up a new container. That hard drive is going to be plugged back in again at that exact location. SQL Server is going to start up. It's going to read master. Master is going to have the description of all the databases, all the user databases associated with that instance. And if all of those databases are available on the file system that has access to, all those databases come back online, right?
That's cool. Thank you.
Yeah, it is. It's cool to see it because, someone said it in the chat. The idea of kind of breaking like the dependency of computation and state really unlocks a lot of what's the word I'm looking for, possibilities and how we could service our applications. Because I like to make this joke when I talk about high availability. Nobody cares if SQL Server's online. They care if they can get to the data, right? And the idea here is I'm just going to put a container to get access to the data that just so happens to be physically sitting on a disk somewhere, right? And that's really all a container orchestrator is going to do. It's going to stand up a container, attach that disk, and send the traffic that I want to that container that gets me to that thing. And so that's really the concept that is neat to me, because as long as I have that container there, regardless of where it is in my cluster, I can get to that data. I have to protect the data, with whatever I should be protecting that data with to keep it online. But that's a responsibility of me as a systems person, right?
Right. There's a basic simplification that you just stated of users don't care, they just want it there. But the SQL admin and the accidental SQL DBA who's trying to do this to keep it online, there's a substantial amount of effort and work to make sure that every time you click into 1433, you're getting a response back.
Yes, absolutely.
And so it's the magic hiding of the unbelievably complex scenario behind. If I'm going to try to sell this to an admin or a DBA, you got to be able to tell a DBA who's been doing this for many years on-prem, says, yeah, you're going to be able to tune your database so that your disks will perform at the rate that you're used to, so your IOPS makes sense.
Right.
I mean, a good DBA spends 50% of his time tuning queries and the other 50% getting IOPS out of his system.
Yeah, and so if you look at how so Microsoft handled that in Kubernetes and also in Azure Arc-enabled data services. So effectively, what you do in Azure Arc when you define I want to consume storage for SQL Server is, it's really, I like that. It's a good question, Glenn. What they did is they kind of abstracted out storage classes. So for example, like in Azure, there's local redundant storage, premium SSD, ultra disk, right? And what that PVC thing that I showed you in the code that just goes and asks the cluster for storage, that's how Microsoft handled it in Azure Arc-enabled data service. They kind of gave you this ability to define classes of storage, right? So you can have you can kind of bring that paradigm of cloud to wherever you have data, even on-prem. So you can define, the tier 1 gold, the tier 2 not so fancy, tier 3, whatever. And then even within that, you can fan that out for transaction logs and data files, and I can attach multiple for different types of data files. And so that's a design thing that we've done probably in spreadsheets and whiteboards for years, but now we got to do it in code, right? And so, and that's still our responsibility as data professionals, because I got to make sure that the bits and the bytes are flying off the drives as fast as they can, right? When is it not a good idea? All right. So the biggest thing for me is people. Then there's no one's going to rip out their production Windows boxes and drop in SQL Server on Kubernetes. It doesn't provide any value, right? Today, that's tangible. But if your organization is shifting to DevOps, it's shifting infrastructure as code, and you're doing those things of defining microservices and things like that, that's when it becomes a good idea to look at SQL Server and Kubernetes, because it becomes part of your stack. From an engineering standpoint, if I have to build a team, I don't want to have to build a team of Linux microservices, Kubernetes experts, and then have a Windows platform team to support SQL Server. I've seen it in production, right? And both of those groups are really expensive. So if I'm a CIO or a CTO, I'm going to make sure that if I pick a platform, we're doing this on Kubernetes, we're doing it on Linux, and for whatever reason, we're using SQL Server. And so that's when it's a good idea. And so that's really the inverse of that is when it's a bad idea. It's like when you don't want to just force it in there to do it, right? So because that doesn't provide value to the org.
So I see Caesar has been waiting patiently here. Caesar, you have a question? Would you want to come on mic and ask your question?
Yes, hi, how you guys doing? Thanks for taking my question. I have a question about something I was running into last year. I got introduced to containers, and I was working on containers on Linux VMs.
Mhm.
And eventually I got into Kubernetes, so building Kubernetes clusters. So running a master node on one server and then worker nodes on two separate Linux VMs. And it was working perfectly until we started Linux patching. So anytime we would run Linux patching, the Kubernetes cluster would break. So then I would have to go in and do I forget exactly what I was doing. I did document it though. I had to go into the worker nodes, fix something from there, and then actually generate a new token to join it to the master node. So, so I had to do this constantly, after patching. I did some research online, and pretty much everybody was just saying, move your Kubernetes cluster to the cloud, right? And so I eventually I moved to a different company, and now all I do is Kubernetes in Azure. But for those companies that are still on-prem, how do you go about that? Like, what's the best practice for that? Maybe I was doing something wrong, because essentially what we did to work around that is we stopped patching those Linux servers as a workaround to avoid the downtime.
So, all right, do you see this GitHub repo on the screen?
Yes.
No, we see the file system.
Ah, man, who is this rookie? All right. Were you doing this when you installed your stuff? Were you marking your packages as hold when you deployed your Kubernetes clusters and built them from scratch?
I might have. I do have. I couldn't say for sure, but I do have the documentation. I could take a look at it.
So yeah, so what AppMark hold does is basically says when I want to run app update the OS, don't update these guys because I want to service these independently of the security patches of the operating system, right? And decouple those processes because this process, the upgrade Kubernetes, is a defined process, and it's in the docs and how to do it with regards to upgrade the kubelets and then the cluster and then failover nodes and things like that. It's a real structured thing to do, and so that's as long as if you're doing this and then following the cluster upgrade process, things should come out a-okay. So maybe double check and see what you were doing there. Then that's one school of thought though. The other school of thought is upgrade the control plane node, formerly called the master node, and then just bring in new nodes and then offline the old nodes. These new nodes are patched, right? And that way you can just kill these old ones off. That's another technique, and that's how Azure does it when you're doing upgrades inside of Azure instead of node pools.
Mm-hmm. Oh, that makes sense. Thank you.
Yeah. Thank you.
All right, so I think we need a way to wrap this up here, right? Probably end up with questions forever, but we are recording this, so why don't we finish up? First of all, again, thank you for doing this. It was really, really, really informative and just blows my mind how it all comes together. But I was just thinking, you kind of got started with your presentation and went right into it, but you've been given some links and stuff. So if people want to find more about you online, how do they do that?
Yeah. Let me bring that back up. I will put this on my GitHub, probably like I said, first thing in the morning. Let's see.
And Anthony has a very active blog. I've been to it a bunch of times. I think you are better than me. You post something every 2 weeks, it looks like, at least.
Yeah, it's been a lot more lately too. I've just from stuff I've been seeing at work. So here's my Git.
And again, we're looking at a pretty screen view.
Dropping in the chat.
Okay, gotcha.
And blog is here. I'll send you an email, Mike, so you can distribute it to the group with
Sure.
all the assets.
Sure.
And then Yeah, so you guys can have access to all that fun stuff.
So for the people following along at home and they might not have access to the chat, you can see Anthony Nocentino on his blog at nocentino.com. He also has a GitHub repo with his last name at github.com/Nocentino. Lots of valuable resources out there, so definitely check it out. And as Anthony was alluding to earlier, he's very active in the community and is doing demos all the time, so a great follow online as well. So definitely, there we go. There we go. Lots of good things to share. But so with that, I'd like to thank the people who watched online. And if you enjoyed this, come and check us out at rtpsug.com, or you can find us on Meetup, the Research Triangle PowerShell User Group. We meet twice a month on the first and the third Wednesday of the month. And the benefit you get in joining us live is you get to ask questions to the speakers and interact and have a lot of fun with us. So we hope you join us. And with that, we want to say thank you to Anthony for presenting tonight. It was such a blast, and I hope you enjoyed it as much as I did, Anthony. It was really fun.
I did. I want to put a shout out to the audience. Thanks for asking questions and good questions. Like, I know it's this whole virtual thing has been tough and stinky, but honestly, you all have like knocked out of the park. So I appreciate y'all asking good, tough questions. Thank you.
Yeah. So with that, we're going to say good night to everyone and see you soon.